In this video, we're going to talk about complex numbers. The set of complex numbers includes both the real numbers, which would be any number you can measure, and what are called imaginary numbers. So the format for these complex numbers, which include the imaginary numbers, they look like a plus bi, where a and b are real numbers. A is usually called the real part. B is called the imaginary part because it's multiplied by I. So what is I? I is called the imaginary unit. It's not a variable, it's more like a constant because I always represents the same number, and that's this square root of -1. So anytime we come across the square root of something that's negative, we can use this I so that we're able to carry on with our calculation and not sort of get stuck there. Because I is the square root of -1, if we were to square both sides, squaring a square root symbol, right? The square and the square root are opposite operations, so they would cancel each other out. So anytime we see I squared, we can replace that with a -1. The place where we're going to see the complex numbers show up the most is when we start to solve equations that are quadratic or have an x squared in them. And so we're going to be simplifying things that look like this. I want to show you the process for simplifying this so that we can use the I. Once you've seen the logic behind how we're going to simplify it, from then on, we'll probably just jump from point A all the way to the bottom to point B. Right? So let's look at the square root of -3. We could break up the -3 into two parts that are multiplied -1 times 3. That way we're sort of isolating the negative. And then for a square root or any radical, we're allowed to break up the square root over multiplication, so that we have the square root of -1 and the square root of 3. The square root of -1, we said we're going to use I to represent that. So this would be I times the square root of 3, or the square root of 3 times I. Okay, so these steps in the middle kind of show you how it's possible for us to use the I. Now that you've seen this logic, very often we're just going to jump from the negative under the square root to the I on the outside. All right, so take a second and try this one. What about the square root of -4? What would that be? We could work it out the same way, although I don't think we need to write out those steps, right? This would be like -1 times 4. So definitely have an I. And we can take the square root of 4. That's just 2. So this would be like 2I. Okay, let me add one example here. What if we had 3 plus the square root of -100? Let's try that. So what would the square root of -100 be? It's negative, so there's going to be an I involved. And the square root of 100 is 10. So that would be 3 plus 10I. Okay, so I would say that this skill would probably be the most useful. That's what we're going to build on in the next section. But there is some more information we could look at in regards to complex numbers and how they operate. So let me show you a few of those ideas as well. Let's start with adding and subtracting. So when we're adding and subtracting, basically we're going to treat the I as though it were a variable, sort of like x it's not a variable. We've talked about that, but it sort of acts like a variable. So we could take two complex numbers. Notice these are in that a plus bi format, and we could add them or subtract them. This one is subtracting. So there's an extra step when you subtract, especially if you're subtracting something that has more than one part, and that is the distributing the negative. So this becomes 12 plus 8i minus 4 plus 6i. And at that point, we can just collect all the like terms. So all the real numbers, we could collect those together. And all the complex or imaginary parts here, the terms that have the I, we could collect those together. So that gives us 8 plus 14i. Okay, in a similar way, we could do multiplying. So remember that we said the I squared equals -1, because that may come into play here when we multiply. So I could multiply this together if I sort of treating the I like a variable. I times I would be I squared. But we said I squared was -1. So this would be the same as -35 times -1, which is just going to change the sign to +35. Okay, if we're multiplying two complex numbers that have two parts, these are sort of like binomials. So we can use FOIL here. We haven't taken the time to talk about FOIL, I don't think, but this is the first, outside, inside, last. So we could use that idea here. First times the first would be 15. On the outside, I have minus 20i. On the inside, I have plus 21i. And then the last times the last would be a minus 28i squared. These two terms in the middle are alike, so we could combine those. So that would be 15 plus 1i, or just I. And then here's that I squared again, so I'll write it out, but really that I squared is going to change the sign of this 28 and make it positive. And then we're able to combine 15 and 28 together to be, what is that, 43 plus I. And we're going to write our answers if this applies in that A plus BI format. Okay, one more special type of pattern that shows up for complex numbers. You could have two complex numbers that are called conjugates of one another. So that means one has a plus and one has a minus. And something happens when we multiply two complex numbers that are conjugates together. So let's kind of carry out that same FOIL process and see what that pattern is. So if we FOIL these out, this will be 4. On the outside, I'll have minus 10i. On the inside, I'll have plus 10i. And then the last times the last will be minus 25i squared. These two terms in the middle add to be 0. That's what makes this a little bit special. So I'll have 4 minus 25. I have an I squared, so that's actually -1. So really this is 4 plus 25, or 29. So notice I took two complex numbers, I multiplied them together, and I got a real number as a result. And so that's what makes multiplying conjugates special, right? We have removed the I, or the imaginary part, by doing that. All right, there is more in this section than what we've discussed here as far as matching up with the textbook. This is what we're going to focus the most on, but you're welcome to read about dividing complex numbers that makes use of this conjugate idea, and I raised to various powers. You could look through that as well if you were interested. All right, I hope this gives you a good understanding of complex numbers. We're going to build on this in the next section, so it'll be worth putting in the time to practice it now. Good luck.